Hey, what's up? It's Václav here. It's spring, best time to make irrigation. Now, I've built mine some time ago and I'm not gonna dig it out and do it again with you, but what I'm gonna do is I'm gonna show you how I did that so you can repeat it. Now, I didn't start from scratch to build it for Home Assistant. I used to have this Gardena installation that consists of the Gardena sprinklers, valves, and the 4040 control box. But it doesn't mean that if you don't have the Gardena that you can't do it, or that you have to buy the Gardena if you want to do it from scratch. I'm actually replacing this control unit by Sonoff 4-channel Pro. So if you're starting from scratch, you don't have to get this unit in here. I'm actually not gonna use it, and you can go for the Sonoff right away. But you can still use those valves from Gardena, those 24-volt AC valves. I'm gonna show you and give you a link to those. Or you can use any other valves, I guess, because all I do is I use those relays from the Sonoff to open them. And again, for the sprinklers and for the tubes, you can use whatever you want. I'm gonna focus on the control system. So let me show you how I did that. So this was the old irrigation. It takes water from a garden faucet and feeds it to those 4 valves in those green boxes. These are controlled by a Gardena 4040 box that can be programmed to open and close them. Now, when I trigger one of the circuits manually, it sends water to the sprinklers and starts watering. I picked Gardena because it was simple to use. They have this plug-and-play system where you just push the tube into the connector and twist it, and it will seal it. And it is available from the local hobby markets. I do not have to ask specialized company to do it. So I did that a couple of years ago before I had Home Assistant. Now the challenge was, how do I upgrade it and automate it so I can control it from my phone and use all this weather forecast information inside Home Assistant to manage this better. Now when the valves close, the sprinklers will lower down and hide. That is quite normal, I suppose. So this is my plan. This is the existing Gardena controller with the 4 valves. It is powered by 24 volts AC, and the way it works, it's simple. It just sends the 24 volts to open them and disconnects it to close them, which is great. I was looking at videos of some other valves using 9 volts DC, I think, and the way they worked was they were sending a pulse of a specific voltage and length, I guess, to control them. And doing that would be quite tricky. In this case, all I need is to have 4 relays. Now, I can probably build such a thing, get some ESP8266 or ESP32 microcontroller, get 4 relays, power supply, and that's it. But as usually, I'm lazy. So I went for Sonoff 4-channel Pro because it just does all I need. The Pro version has galvanically isolated relays. So what I will do is I will take the 24 volts from the Gardena and connect it to the common connector for the 4 relays. And then take the normally open connector for each relay and connect it to the valves. So when I close the relay, the valve should open. That will be easy. Maybe too easy. What I want to also do is I want to run this independently from the Home Assistant. So if I lose Wi-Fi or restart Home Assistant while the valves are open, I want them to finish the scheduled job and close the valves. I don't want the water to run indefinitely. To do that, Home Assistant will need to set timers when opening the valves, and the rest should happen automatically. And I also want to have some display to be able to control it directly, so I don't have to run to the computer when I'm in the garden, and I want to know what's going on. For the display, I will use my favorite iTeat Nextion HMI, and that needs 5 volts. And the Sonoff can also run on 5 volts. So what I will do is I will just get 5 volts adapter and I will use it to power the Sonoff. Looks like I could have gone with the generic 8266 after all. but at least I don't have to worry about soldering in the box. With that, I can remove the Gardena 4040, or I can just leave it there. It doesn't do any harm. It looks like irrigation is very important to me because I will have a fully redundant control. So now we know what to do, so let's get started. This is the display. It has 4 wires, ground, RX, TX and 5 volts. Pretty basic. So all we need to do is to find them on the Sonoff. So for the 5 volts, we take them directly from the power supply. We tap to one of the grounds and then just simply connect TX to RX and RX to TX. Before connecting the display, I'll need to upload the HMI layout. And I've created one in the screen editor downloaded from the Nextion website. So all I need to do is to connect the display to the computer using FTDI adapter. So again, ground to ground, 5 volts to 5 volts, RX to TX, TX to RX, and then plug in the USB, compile, and upload. The last part in completing the hardware is to cut the hole for the display. Before doing that, I suggest you check the space inside the enclosure to make sure that there are no components in the way. I made a mistake and I put it a bit too much to the left and I had trouble closing it. So put a bit to the right to avoid the coil. Then I cut a small piece of a paper the same size as the display. That was 5 by 3.8 centimeters. And I used it to outline the shape for the hole and then just cut it. I used Dremel to do that because it was simple. Then cut the corners and the inside will pop out. And then just clean it up with the file and give it a small bevel. To fix the display, I have glued 4 pieces of MDF into the corners by a hot gun. So now we can just insert the display and secure it by 4 screws. Now we can close it, mount it and use it. But before we do that, let's upload the firmware. For the firmware, I'm using InHome, which is the easiest and most flexible option in InHome Assistant. I'm sharing the code in the GitHub, which is linked in the description of this video. And what I'm going to do now is I'm going to walk you through the code and explain you how it works. So if you want to modify it, you can do that. So this is the code. The first section is substitutions. This is entirely optional. This is definition of the constants used throughout the code. And I like to do it this way. So if I need to change some GPIO ports or some of the timers, I don't have to search them through the code. I have this header where I can change them and the code will be updated instantly. The next section is ESP-Home. I think it exists in all the ESP-Home scripts. That basically says what is the name of the device and what is the microcontroller chip on the board. The next section is logger, which is the configuration of the logger through the serial interface. And I don't use that, but more importantly, I have to disable it because I'm using the RX and TX to connect the display. And to disable it, I just set baud rate to 0. With that disabled, there is the section for the asynchronous receive transmit interface. So I'm configuring the pins used for that and the baud rate 9.6K. So this is the configuration of the connection to the display. The next section is globals. These are global variables. Most interestingly, the timers. So these are countdowns which count from the initial values, and I will decrement them until they reach the value 0. And when they reach 0, I will open the relays and shut down. So this is the way Sonoff actually works autonomously. Even if it loses all connections after the time expires, it will automatically shut down the valves. These are the initial values for the timers, which I can change from the Home Assistant, and by doing that I can control the time for the different valves to be open. And I do that through the services that are defined here in the API, and these are services and service handlers to set those initial values. Above that there is a section for Wi-Fi. I don't have to explain that, this is in all the ESP-Home scripts. Then there are binary sensors. These are basically the buttons on the device, and it says what it should do when I push a button. There are two types of buttons. The first ones are the GPIO, that are the 4 buttons actually on the Sonoff 4 channel, the 4 buttons on the left. So key 1 to key 4. And when I do that, I basically say that on press, I will set the timer to some initial value, and I will toggle the relay. It's actually not only turning them on, but if it's on, it's turning them off. So I'm using the function switch toggle of the particular relay. And then I have a few of the platform Nextion, and these are the buttons defined on the touch screen of the display. So I have 2 buttons that are calling scripts, that are opening sprinklers in the sequence, and by doing that it will irrigate different sections of the garden one after the other. And I have 2 programs for that, one for the full garden and one for one of the sections. And then what I have also defined is on the display there are those 4 columns representing those 4 relays for the 4 different circuits, and I actually define them as buttons as well. So when I push them with the finger, they do exactly the same as if I would press the physical button on the box. I thought it's kind of more intuitive doing that. Then I have some sensors. These are representations of actual sensors on the Home Assistant, and I use them to display them on the display. To have information about, rain and temperature, and also the status of the alarm, which I use to turn the display off when no one is home. Then the section display. That's probably the most interesting one in here, and what it does is it's actually updating text on the display, and it's using lambda code, so it's kind of written in the C code. It's a feature of the ESP Home. I'm gonna make a video about those displays, so I'm not gonna go into detail, but basically the way it works is in the HMI editor I have designed the page with different components, and the components have names. And from the code I can set the parameters of those components, so in this case text of a text box to specific value. So in this case I'm using the value from the Home Assistant sensor, but in here I'm actually showing the value of the timer. Then there's a value with the switches, which are the relays. And what I do with that is I have an action on turn on, so when the relay is turned on, I basically set the timer to the initial value, and from then on I start the countdown, which is in here in the next section. So this runs in 5-second interval. I've learned that the optimal update interval is 5 seconds. If I made it shorter, I've tried with 1 second initially, and it was causing issue. It didn't finish all the updates in time. So I'm making it 5 seconds, and what I do that is I decrease the timer by 5, and if the timer is equal or less than 0, I turn off the relay. And it's basically all there is. So what I do is I will go in those 3 dots here, I will compile it. Once this is finished, I will just download the bin file, place it somewhere on my desktop. And once we have it, we need to upload it to the Sonoff. So I'm not gonna show you how it's done. There's plenty of videos for doing that. But in short, I need to connect the Sonoff to USB using the FTDI adapter. When I connect it, I need to connect shortly the GPIO 0 to the ground and connect it. And then I'm using this ESP Home Flasher to upload the firmware to the device. So in here, I will select the port. Once it's connected, I will choose the file which I have just created, and then say flash ESP. With that, the Sonoff is finished, so we can close it, put it on the wall, connect the wires, and plug in the power, and we are done. Let's test that. I'm gonna push the first button. It will open the first relay, and the sprinklers are on. I see the time, and it's counting down, and when I push the button again, it will close the relay and turn off the water. So everything works. Now we can add it to the Home Assistant. Now once we're in the Home Assistant, I'll get notification that there were new devices discovered. So it's ESP Home Irrigation, I call it in Czech language. So I'll say configure, submit. Here I have to enter my API password that I have my secrets. And it's success. I will say this is in the garden, or I think I call it outside, and I'm finished. So I can check it out. It created 4 entries. I'm going to rename them. And we are in Home Assistant. I have previously added them to the Lovelace. So what I'm gonna do is, hey, what the heck, I'm gonna just delete it and create it again so you know how it works. So I'm going to delete this glance card and I'm going to add it again. So it will be a glance card. This will be the relay 1. This would be the relay 2. This would be the relay 3. I will add the 4th. And in here I will add the script, which I'm going to show in a second. Also, I don't want to show the state, so I'm gonna just turn this one off and I'm gonna save it and exit from the editor. So this is how it works. I have those 4 circuits. So if I turn it on, you should see actually in here in the camera, it'll start irrigating in a second. And you see, here it comes. So I'm going to turn it off. And then there is this script. So this is the script to irrigate the whole garden. It's sequentially going to turn off the circuits 2, 1, 3 for 900, 900 and 600 seconds. So I'm going to make an entry in the log so I know it's been running. And then I'm going to remember that the irrigation sequence run in this variable in here. And I'm going to show you in a second how I use that. So I'll remember that it was used. And then I just call the service ESP Home Irrigation set time to 900, the timer 2. And I'm going to turn on the switch relay 2. Then I'm going to wait 15 minutes. And then I'm going to turn it off. And I'm going to turn on relay 1 and then 3. And it's done. And then I have the second program in here. So this is the sequence to irrigate the whole garden. And in here I have another sequence to irrigate one part of the garden. So I have different scenes, if you will. So that's all nice that I can turn it on from the web interface, but obviously this is not how I irrigate my garden. What I do normally is I have a calendar. So I actually use integration with the Google Calendar. And here I have recurrent events in the calendar for the relay 1, 2, 3, and 4. I think it's going to be easier if I show them to you in the Google Calendar directly. So here I'm starting at 2 o'clock. I'm starting with the relay 2 for 15 minutes. Then I have relay 1 for 15 minutes and then relay 3 for 10 minutes. I'm, by the way, using the same calendar to set the covers and also to control circulation of the hot water. And then I have those calendars set up in here using the standard Google Calendar integration. And I use them back in the automation. So what I do is when the calendar for the circuit 1 turns to on, then I'm checking a couple of conditions. So the first one is I have this master switch for the irrigation, and I do that for all the automations, so you already saw it. I'm also checking the rain, and also I'm checking whether the program hasn't run in the last 24 hours. So if those conditions are met, then I'm going to basically set the time based on the attribute from the calendar. So based on the duration of the calendar, I'm gonna set the time. I'm going to turn on the irrigation and I'm going to make a note in the logbook. Now this will automatically turn off by the Sonoff, but just to make sure, I'm also having a automation when the calendar event turns to off, and I'm going to turn off the relay just to make sure. Now if I look at the history, you could see that here are the 3 relays that run. So first the second, then the first, and then last was the third one. Now there are a couple of conditions that check the precipitation. Currently I'm looking at the values from last 3 days and today. I'm also checking how the forecast is reliable, and if it is, I'm going to also check whether there is a forecasted rain for today, and if there is, I will also stop the irrigations. Now for the rain, I have this Z-Wave sensor that I have positioned outside, and I have an automation that runs every day at midnight, and I'm basically moving the value from the previous day to the next day. So I'm kind of shifting the memory of how much precipitation there was every day. So I have some history of the rain during last 5 days, how much rain there was in the last 5 days. And here at 8 o'clock in the morning, I'm also resetting the flag that remembered that the irrigation program ran in the last 24 hours. So this works well, but it's a little bit cumbersome, so I'm working on a next version which is going to be a little bit more intelligent. I'm going to probably move it into Abdaemon, and I'm going to connect it with some other logic to do a bit more proactive control of the temperature in the house, perhaps using some historical data and artificial intelligence. So I'm researching it right now, and once I have it done, I will make a video about that. And that's it. I hope you like that. Let me know in the comments under the video. Now, in one of the future videos, I will talk more in detail about the displays I use in here. I use them in a couple of other places, and I've got some questions from you, especially about the display I have by the entrance door. So I will make a video about how you design the HMI, how to programming, how to use it. And if you want to make sure you don't miss that, just hit the subscribe button below. All right, that's it. See you later. Bye.